Today we will show you a short movie about the Maritime Museum. It's about some technical aspects of the building and especially the internal climate and how this can be improved by the use of natural sources. Our building is situated in Europe, to be more precise, in the Netherlands, in the city called Rotterdam, and in the neighborhood called Stadsdriehoek, which might be the reason for the shape of the building, a triangle. The Maritime Museum is located near the train station Rotterdam Centraal, the Nieuwe Maas, the harbour called Leuvenhaven, and it is adjoined to a big traffic point between Blaak and Schiedamse Dijk. This is what the building looks like from a northern point of view. As you can see, the facades are very closed. The south side of the building is a bit more articulated, but also these facades are very close. The Maritime Museum is surrounded by a lot of buildings, of which a few of them are pretty high. But, as you can see, most of the shadow of the museum is caused by the museum itself. This made us wonder how the sun affects the temperature of the building. We will look from a southern point of view. The part that heats up the most is the roof, including the terrace. The southwest facade becomes most warm after that. But also the southeast gets a lot of sun. The coldest part of the building is the part that is shaded by the building itself. Typical for these spaces is that they are very dark, but at the same time are these the places that have the facade made of glass. The problem here is that a lot of heat is lost, especially in winter when there are cold days. That's why we have chosen to focus on this section to improve the internal climate of the facade by changing the outer shell. The focus should be on one surface, which could be either the roof or the facade. Individually, we've worked on either of these, but as a group we have focused on the roof. Let's look at the current situation in a section. In summer, a lot of heat is gained on the ground floor because of the glass roof close to the terrace. It gives daylight in this space, but also a lot of heat. In winter, the glass facades are almost all the time in shadow, which means that a lot of heat is lost. A lot of energy is needed to keep the right internal climate. To improve this situation, we asked ourselves, how can the internal climate of the Maritime Museum be improved by changing the roof and by means of natural sources? We started by altering the building, got rid of the glass roof, added a concrete volume, closed the gap with an angled roof, put blinds on the glass parts, made a connection with the harbor by placing a heat exchanger, a high efficiency chiller, which can also be used as a condenser, and the air handling unit to complete a new system. In addition, we placed some photovoltaic cells on the roof to provide the machines with energy in optimal position of 36 degrees to the south, and turned the roof into a vegetated roof for better insulation. So, how does this system work? Let's start with summer. In summer, the sun is at a very high position, about 62 degrees, and will be blocked by the blinds. Fresh air is sucked into the system from outside. To cool this air down, we could use the colder temperature of the water. Via the heat exchanger and, if necessary, the condenser, the air can be cooled down in the air handling unit before blown into the building. As the air gets warmer, it will start to rise up. Hot air can leave the building by an opening in the roof or the glass facade. Heat that is produced in the machines can be disposed in the harbor or to the outside air. In winter it is a bit different. The sun is at a much lower position, which is about 15 degrees. This means that the sunlight can enter the building. The mass put in the building will be warmed up by solar radiation. Again, cold air is sucked from outside. Since it doesn't have to be cooled down, the chiller can be on standby. If the temperature of the air is colder than the temperature of the water, the air can be warmed up a bit by the warmth can be gained from this difference. The air handling unit will heat up the air to the demanded temperature before it is blown into the building. The hot air will rise up, the roof will be closed, and the still air will be extracted and led back to the air handling unit where the warmth can be regained and reused. The still air will be exhausted to outside. At night, the mass that is warmed up will spread a bit of warmth by radiation to keep the temperature more consistent. Our solution is based on the Barden Eco House in Madrid, which makes use of a sloped roof, lets warm air escape in summer, and uses a mass for radiation in winter. The second reference is the Harbourside project in Bristol, which uses the water for cooling air and regains warmth from the still air. The only difference is that this is an office building, so there is mostly about cooling. As a result, this is what a new Maritime Museum could look like, and this is our final solution for our redefined roof. Thanks for watching.